In this video, we're going to be taking a look at the tool library from inside of BobCAM for SolidWorks. But when my SolidWorks is loaded and I have a blank screen, right now I do not see BobCAM listed. So first I need to turn it on. The easiest way to do that is just to go up to Tools and then all the way down to Add-ins. Now when we open add-ins up, we'll notice that currently I do have it used to do a startup, and the time is super long right now because during that time I was shooting the video for how to register. So that's how long it took to register and everything for me while I was shooting the video. This, after your initial registration, should be a lot faster. So if you're having really slow loading times for BobCAM, this is where you're going to want to look. For now, I'm just going to turn on the add-on right here just by enabling that button and then hit OK. And then we're just going to wait for it to pop up right up here. Your 3 tabs that show up right here are all for BobCAM. You also have a BobCAM tab right here that you can use. Now to get to the tool library, I'm just going to go over here to the CAM tree manager. Now throughout the system, you're going to come across 2 main places to pick tools. The first place is the tool library. And you could find that by right-clicking right here on CAM defaults and go down to tool library. When you open up your tool library, this is going to be a list of all the tools that are loaded inside the system that you can choose from. Now, at this point, since I haven't defined whether I'm doing a mill job or a lathe job, it gives me all the tools. So the best way to think about the tool library is this is like the shelf or drawer somewhere in your shop that contains every tool that you could possibly put on one of your machines. Later on, when we get into the tutorials for these, we're going to create tool cribs. Now, tool cribs are the tools that you've taken off the shelf or pulled out of that drawer and actually loaded into the machine. They're the tools that we're going to be using to machine the part we're working on. So the tool crib is just to set up the entire carousel for the machine, but the tool library contains all of the tools in the system. So the way that it's going to work is you're going to go from your tool library into your tool crib after you've defined a job. And again, we're going to see that later on in the tutorials that we have part of this video set. So for this one, let's go ahead and take a look at the different tools. We have drills, we have mills, we have lathe tools, we have generic tools. This is where you're going to find probes. We have laser, plasma, and water jet. Now for this one, we're going to look at the mill settings. So I'll just go up to mill. And then right here, you could see a breakdown of all the different tool types that are supported throughout the mill. Now, not all these tool types are supported for every feature. Some features can't use barrel mills, and some features can't use lollipops. But for the most part, the tools that you add in here will be able to be used in certain features when you're going through your job. So right here we have our end mill rough, end mill finish. We have chamfer mills, corner round mills, thread mills, single point thread tools, V tools, taper tools, T cutters, dove mills, lollipops, and even a drag knife. And if I scroll down in here, the next section is all the barrel mills, which are primarily used for multi-axis machining. So I'm just going to use a end mill rough here. And then right here we have all the different tools. Now you can click on each one of these categories to sort by that category. So I could sort by my tool number right here just by clicking that tab, or I could sort by the tool label. The one I primarily use is sorting by diameter because that's usually how I'm picking my tool. We could also sort by corner radius, number of flutes, the flute length, the overall length, and if we move over a little further, the tool material. Now, if I bring this back, another way to look at all the tools that you have is by grabbing the actual title block here and dragging it to this column right here. So we're going to grab this column header and drop it right here. And what that's going to do is it's going to sort just the tools. So what we do is if we open up a 1/2 inch, I don't have just one 1/2 inch tool in my system. I have a 1/2 inch standard tool, so it's going to be a little bit shorter. I have a 1/2 inch long tool, so it's going to be a little bit longer. And then I have a 1/2 inch ball mill. So this gives me the ability to pick tools very quickly just by their diameter and what their length is. And this is how I would sort a lot of them. And if I don't want to use it, I just X out of it. After you pick a tool, you could either modify it or you could keep it the same and just use that entire job. Or we could add a new tool. Now to add a new tool to the system, we're going to go down here and hit this green plus sign. And then when it loads up, it's always going to put it at the bottom of the list as the tool numbers go. So if I scroll all the way down, it's always going to create the latest or last tool number that's added to the system. Now to modify this tool, I could just double click on it and it opens up the tool parameters, which you could also find right here on the right side of the screen. What we're first going to do is we're going to add in the tool label. So I'm just going to say 1/2 inch flat end mill. And then I'm going to put a little dash here and say carbide. Now, a lot of the tools that get created with the system by default are made from high-speed steel, which we can see right down here. I'm going to be able to go in and change that. And you can modify any tool just by double-clicking on it and making these changes. So when we create the tools, and it's going to be different for every tool, but the functionality is pretty straightforward. We have our diameter, our flute length. If we have a corner radius, we could enter our corner radius. The number of flutes, the overall length, the protrusion length, or how much of the tool is actually sticking out of the holder, and then the tool number. Now right here for the tool material, I'm going to change that to carbide so that when I go and use this tool, it's going to calculate the feeds and speeds based on the tool being carbide, not high-speed steel. If I scroll down into here, we then have our holders. So we can actually attach a holder to this tool. All we have to do is say assign tool holder, and we have CAT 40, CAT 50, and BT 40 holders. I'm going to go ahead and use a CAT 40. I'm going to pick my 1/2 inch ID arbor. And then if we wanted to edit the arbor, we can actually just say edit arbor, or we could edit the holder or create new holders. So if these three aren't one of the types you're using, go ahead and add a new holder. Primarily what we're using this for is simulation. If the holder or anything gets in the way and hits the part, then we want to know about it. But if you don't pick a holder, you won't have a really true representation of the proper tool inside the simulation. So I always like to add holders to mine so that I can see what the tool is going to look like as it's cutting. And as long as I use a defined holder, if that holder comes in contact with the part, I'll be notified through the simulation that I'm having a collision. So having a holder is very important. And the way that the holders and the arbors are made is if I just say edit arbor, we could see it's built with just cylinders and cones. We have a cylinder to create this top kind of flat area. Then we have a cone, a cylinder, and a cone. Now, when we define a cylinder, we define the height of the cylinder and the diameter. When we define a cone, we define the height of the cone, and then the top diameter and the bottom diameter, and then back to cylinder, back to cone. There's only 2 features that you use to create this, and all you're trying to do is draw out this kind of front view of what that holder is going to look like. It does not have to be perfect. It doesn't have to match perfectly, but you want it to be pretty close because, again, we're going to use this to represent the holder, and if this touches the part, we want to know about it so that we can fix the issues that we're running into. So you set up your holder, you hit OK. I'm then going to pick my 1/2 inch ID arbor and then hit OK again. And then if I scroll down, the last bit is using or not using feeds and speeds through BobCAD. Now, if you have a program that you use that generates feeds and speeds for you, then for the most part, you'll do your feeds and speeds. Inside the feature of the actual toolpath. So you could set the depth and the step over and all that stuff. If you want BobCAM to figure out the feeds and speeds, you're just going to leave this button checked, and you're going to say use system feeds and speeds. And we're going to use the material library, which we'll see in a later video, and actually connect the two together so that through the material library, it knows what category to pull from. So the main 3 are high-speed steel, carbide, or insert. If we wanted to put in feeds and speeds that we are going to use every time we run this tool, maybe you have a router and you're just cutting wood, so you keep the same feeds and speeds every time. What we could do is just uncheck the Use System Feeds and Speeds button, and then we can manually enter in our spindle RPM, our plunge feed rate, and our cutting feed rate. And these would be numbers that every time this tool specifically gets picked, regardless of what BobCAD does for the Use System Feeds and Speeds, these will be the feed rates that open up and show up inside the code. The last part of this is for creating form tools, which is a tool that has a specific profile on it, kind of like a router bit. If you were doing like a round over cut with a hand router, you could just use a round over bit to get you a nice radius corner. These essentially work the same way, except it allows you to create that custom geometry. When we say assign tool geometry, it's going to ask for the custom shape of the tool and then the coordinate system as a reference. If you want more information on that, be sure to check out the help system because it'll actually walk through how to create those custom tools. For me though, I'm not going to add any custom tools, and I'm not actually going to use these define feeds and speeds. I'm going to let BobCAM figure it out as we go through our features. But just know if you have a tool that you're not going to be changing feeds and speeds on very often, going in here and setting up the use system feeds and speeds can be very helpful. And after we're done, we could just move the tool parameters over. And now with this new tool, we could pick that, put it inside of our tool crib, and it would actually be a tool that we could use inside of our feature. For now, I'm just going to hit OK. And that concludes the tool library from inside of BobCAM for SOLIDWORKS.